Hello everyone, I'm Jessica Kale, currently pursuing first year MBA at Sri Venkateswara College of Engineering at Bangalore. I have an assignment a topic of Jimmy-wide association studies. Meaning, genome-wide association studies are the powerful tools in statistical genetic. They involve scanning the genomes of many individuals to find genetic variations associated with specific diseases or traits. Advantages: discovery of genetic makers. GWES can identify the genetic variants associations with diseases or traits, leading to a better understanding of the genetic factor involved. Second point, large scale analysis. By studying thousands of even millions of genetic variants across the genome, GWES can detect the associations that might be missed in a smaller studies. Third one, personalized medicine. Insight from GWAS can inform the developing of personalized treatment based on an individual's genetic makeup. Next, fourth one, common and complex diseases. GWAS has been instrumental in uncovering genetic factors from common and complex diseases like diabetes, heart disease, and diabetes and heart disease. Non-hypothesis driven. GWS does not require a clear hypothesis about which genes may be involved, allowing from the unbiased discovery of a genetic association. Disadvantages: population stratification. Difference in the allele frequency between population can lead to the false associations if not properly accounted for. Small effect sizes. Many genetic variants identify the GWAS has a small effect sizes, making it changing to predict the diseases risk or development treatment based on slowly on their findings. Missing heritability. GWAS often explains only the small fractions of heritability of the complex traits having leaving much of the genetic basis unexplained. Data interpretation. The sheer values of the data generated by the GWAs can be difficult to interpret and requiring the sophisticated statistical methods and the com- computations resources. Ethical and privacy concerns. The collections and uses of genetic data raise ethical and privacy issues, including concerns about the consent, data sharing, and potential misuse and genetic information. Functions. Genome scanning. GWS involving scanning the entire genome of many individuals, typically thousands of identify genetic variations called single nucleotide pyromesis, SNAPs. Comparison. Researchers compare the SNPs of individuals which specify the traits of diseases to those without it controls by finding SNPs that occurs more frequently in the causes than it controls. They identify the regions of the genome associations with the traits or diseases. Next, third point is statistical analysis. GWS relies heavily on the statistical method to determine the significance and associations between SNPs and traits. This helps to ensure that the findings are not due to the random chance. Next, biological insights. Once the associations are identified further, research is conducted to understand how these genetic variations influence the biological process. This can lead to the identifications of genetic and pathway involved in diseases. Applications. The findings from GWS can be used to develop the genetic test for predicting diseases risk, identifying the potential target for the new treatment, and understand the genetic architectures of complex traits. At the last conclusion. To conclude, Genome-wide association studies (GWAS) has the resolutions of our studies and genetic the basis of diseases. The traits. The function can be identified the genetic variations across the genome that are associated with the specific conditions, providing the valuable insight in the biology understand underlying these conditions, while GWS has some limitations, such as identifying correlations rather than the conclusions. These findings have paved the ways of advanced in personalized machines and the development of new treatment.